This video is sponsored by NextPCB. Hey everyone, this is a macropad, a small keyboard with customizable keys. I work on a lot of complicated software and navigating these sometimes feel like flying an airplane. If you are in this field, you know exactly what I am talking about. Whether it's designing, programming or video editing, it can get time consuming and frustrating. That's why I decided to build one myself. And don't get me wrong, I love using this software. It's just so inefficient to move the cursor all the time or remembering hundreds of keyboard shortcuts. To be honest, it's pretty simple to make a macropad. You just need a microcontroller, a couple of switches, that's it. This is a simple macropad on a breadboard. If you press Ctrl plus Alt plus T, it opens terminal. And with this simple code, I can do the same with a single click. Oh, by the way, I am using Linux, so it won't work on Windows. But I wanted to take it a bit further. Rather than going with a 3D printed body and using a microcontroller board, I decided to make a macropad fully on a custom PCB, which means I'd have to design the microcontroller circuit completely from scratch. And I had never actually done that before, but I decided to go for it anyways. I used the RP2040 chip. It was perfect for this project, especially because of its USB support. I followed the official hardware design guide and also copied the schematic from here. For the macropad, I added a small 3x3 matrix of keys and I am going to use these generic MX switches. Oh, I also added these sockets, so if any of them ever stop working, I can just easily swap them out. I also added a rotary encoder for volume control and an OLED display for layout selection. When it comes to the PCB designing itself, just look at this mess. And now I needed to manufacture these. And here comes today's sponsor, NextPCB. They provide high quality PCB manufacturing and assembly. Because I don't have any equipment to micro-solder all these tiny components myself, I decided to go with their PCB assembly service. In PCB assembly, you will need two extra files other than the Gerber file. The BOM or Bill of Materials, which lists all the components the manufacturer needs to make your board. And the centroid file. It's also known as position file, which locates all the position where the components are gonna be placed. After placing the order, it can take up to 3 to 4 weeks depending upon the complexity. The quality is just insane. Just see this beautiful PCB. If you look closely, from component placement to soldering, everything is just perfect. They also throw in this cool DFM ruler for future reference. Huge thanks to NextPCB for sponsoring this build. By the way, you can get $200 off on your first PCB assembly order. You can use the link in the video description to get your high quality PCB board assembled today. Before soldering the display and rotary encoder, I decided to check if the board was working fine. It was the moment of truth, and I was a bit scared. I plugged the USB cable in and nothing. No USB device detected on the computer. The board was completely unresponsive. I was confused, wondering why it happened. I clearly remember copying the schematic from the official guide and checking it multiple times. It was perfect. It took me hours of debugging and trying to fix the board to find out what the problem was. When I finally tested it with my multimeter, the pin that was supposed to output 1.1 volt was pushing almost 2 volts. It was kind of stupid of me not observing the design on other boards before. You see, while placing the components and routing the traces, I noticed there were multiple power pins on the chip. So I asked ChatGPT if they were internally connected or not. Well, it said yes, so I thought to save space, if I connect all the decoupling capacitors at the same pin together like this, there shouldn't be any problem, right? Well, I was so wrong about this. If you take a Raspberry Pi Pico, you will notice there are these capacitors right next to every single power pin. These are called decoupling capacitors. They reduce electrical noise and they are supposed to be placed as physically close to the pin as possible. Because my capacitors were too far away, the copper traces acted like inductors. This trace inductance caused the RP2040's internal 1.1 volt regulator to become unstable and it started oscillating. That's why it pumped 1.9 volt directly into the core, instantly destroying the silicon when I plugged the USB cable in. I spent hours trying to budge and fix it, but the damage was done. That means no matter what I did, it was not gonna turn on. NextPCB made these boards completely flawless, but my own design mistake killed them. I should have used their DFM tool before ordering. Yeah, they have a tool that you can use to find out these kind of mistakes. If you want to avoid these kind of expensive mistakes, you can use their free DFM tool to analyze your design before ordering. Even though the RP2040 chip is dead on both boards, other components are perfectly fine. In future, I'll try to use these components for a new design. At the end, I wanna say, when designing a PCB, always start with power pins and then move to signal, and always put your decoupling capacitors right next to the main IC. There are multiple things that can go wrong while designing a PCB, so always check it multiple times. If you want to build your own custom electronics without having to microsolder, definitely check out NextPCB and their free DFM tool using the link in the description. Thanks for watching, subscribe if you don't want to miss new videos, and I'll see you in the next one.